Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters in another way. Part 2. So let's get going. Problem. Solve y double dash plus y equal to x cos x or d square y by dx square plus y equal to x cos x using variation of parameters method. So we are given a differential equation of order 2, right? Given differential equation. Y double dash plus y equal to x cos x, or we can write y double dash as d square y by dx square plus y equal to x cos x. Consider the first equation as equation 2 and second is as equation 2. Okay, and we can write d square y by dx square as capital D square y. Just here d is a differential operator. Now take y common from the two terms of LHS. We'll get d square plus 1 into y equal to x cos x. Consider as equation number 3, which is in operator form. Say f of d into y equal to some r of x, where f of d equal to d square plus 1 and r of x equal to x cos x. Right? Let's now write the homogeneous equation of equation 3. The homogeneous equation of equation 3 is d square plus 1 into y equal to 0. Consider it as equation number 4. Now we'll find the solution of the homogeneous equation using the auxiliary equation, and later using the solution of homogeneous equation, we'll write the solution of, or the general solution of 3, 2 and 1, because all the three equations are same, right? The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 1. Let's replace differential operator by m so that we'll get f of m equal to m square plus 1. Then the auxiliary equation becomes m square plus 1 equals to 0. Now we need to find roots to this equation. We'll get m square equals to minus 1. From this we'll get m equal to plus or minus square root of minus 1. Since we know that square root of minus 1 is I, then we'll get m equal to plus or minus I. The roots are complex conjugate. Right? We know that when two roots are complex conjugates, say a plus or minus ib, then the solution of homogeneous equation looks like e power ax of c3 cos bx plus c4 sin bx. Here I am taking c3, c4 instead of c1 and c2 because I want c1 and c2 to appear in the last general solution. Right? Fine. Now in case of a0, we'll get e power 0 into x, which is equals to e power 0 of c3 cos bx plus c4 sin bx. Since e power 0 is 1, so we'll get 1 into c3 cos bx plus c4 sin bx, which gives us c3 cos bx plus c4 sin bx. Right? Now let's write the homogeneous equation, solution to our homogeneous equation. The solution of homogeneous equation is y equal to, just compare plus or minus I with plus or minus ib. Then for b equal to 1, we'll have y equal to c3 cos 1 into x plus c4 sin 1 into x. From this we'll get y equal to c3 cos x plus c4 sin x, which is the solution to our homogeneous equation. Now using this equation, we'll write the general solution of the given equation, or say 1, 2 and 3. Let y equal to, now replace the arbitrary constants or parameters with functions of x, a and b. Will get y equal to a cos x plus b sin x. B, the general solution of 1, 2 and 3, where a and b are functions of x, right? Now if you compare y equal to, this solution with y equal to c3u plus c4v, or the general solution with y equal to au plus bv, we will get u and v, where u is cos x and v is sin x. See, v is sin x, u is cos x. So you have u equal to cos x and v equal to sin x. Now we'll find a dash and b dash using formulae. A dash is given by minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus vu1, right? If you notice, you're having uv1 minus vu1 in both the formulae. So firstly we'll begin with uv1 minus vu1 and later we'll find a dash a, b dash b, right? Here u1 is nothing but derivative of, v1 is nothing but derivative of v with respect to x, minus v into u1 is nothing but derivative of u with respect to x, is equals to u is cos x into derivative of v with respect to x minus v into derivative of u with respect to x. This gives us cos x into derivative of derivative of sin x with respect to x is cos x minus sin x into derivative of cos x with respect to x is minus sin x. This gives us cos square x minus into minus plus sin square x, or we can write it as sin square x plus cos square x, since we know that sin square theta plus cos square theta equal to 1. So from this we'll get sin square x plus cos square x equals to 1. Therefore uv1 minus vu1 equal to 1. Now coming to a dash is given by minus v into r of x by uv1 minus vu1 is equals to minus v is sin x into r of x, x cos x by uv1 minus v1 is 1, which is equals to minus x sin x into cos x. We know that sin 2 theta equal to 2 sin theta cos theta, right? Here you're having sin x into cos x, right? We can multiply and divide this with 2, then we'll get minus x into 2 by 2 sin x cos x, right? We can write it as x minus x by 2 into 2 sin x cos x, so that we can replace 2 sin x cos x with sin 2x, since sin 2 theta equal to 2 sin theta cos theta. Okay, or we can just bring this 2 to LHS. We'll get 1 by 2 sin 2 theta equal to sin theta into cos theta. You can just directly replace sin x cos x. Just replace sin x cos x with 1 by 2 sin 2x, and sin theta into cos theta is 1 by 2 sin 2 theta. This gives us minus x by 2 sin 2x, or minus 1 by 2 into x sin 2x. Okay, so we got a dash. Therefore a dash equals to minus 1 by 2 x sin 2x. Now let's find a using this a dash. We can write a dash as dA by dx, that is derivative of a with respect to x, equals to minus 1 by 2 x sin 2x. Now let's separate the variables by taking the differential dx to RHS, then we'll get dA equal to minus 1 by 2 x sine 2x dx. So here the variables are separable, right? So we can perform integration. Here we are having integral x sine 2x dx. Let's perform a formula using integration by parts. We have integral u dv equal to uv minus integral v du. Here we are having the integrand is of the form product of polynomial and trigonometric function, right? Take polynomial function as u and the remaining part as b. Then we'll have u equal to x and remaining part as dv, and dv equal to sine 2x dx. Now differentiate on both sides with respect to x, we'll get du by dx equal to derivative of x with respect to x is 1. From this we'll get du equal to dx, and here let's integrate on both sides to find v. We'll get v equal to, since we know that integral sine a theta d theta equal to minus 1 by a cos a theta, right? Then for a equal to 2, you'll have minus 1 by 2 cos a x, that is 2x, right? Now coming to the formula, let's apply the formula. U into dv, dv is sine 2x dx equal to u into v. U into v is minus 1 by 2 cos 2x minus integral v. V is, it's minus, right? Minus 1 by 2 cos 2x into du. Du is dx, which gives us minus x by 2 cos 2x, minus into minus plus 1 by 2 integral cos 2x dx. Since we know that integral cos a theta d theta equal to 1 by a sine a theta, right? Then this gives us minus x by 2 cos 2x plus 1 by 2 into, for a equal to 2, we'll have 1 by 2 sine 2x, right? From this we'll get integral x sine 2x dx equals to minus x by 2 cos 2x plus 1 by 2 into 1 by 2 is 1 by 4 sine 2x. Since integral x sine 2x dx equals to minus x by 2 cos 2x, it's 2x, plus 1 by 4 sine 2x, then the integral becomes integral dA equal to minus 1 by 2 of integral x sine 2x dx is minus x by 2 cos 2x plus 1 by 4 sine 2x plus integral constant says c1. From this we'll get a equal to minus into minus plus x by 4 cos 2x minus into plus minus 1 by 2 4s are 8 sine 2x plus c1. So we got a here. Let's now find b dash. We have b dash equals to u into r of x by u v1 minus v1, right? Substitute u r of x u v1 minus v1, we'll get cos x into r of x is x cos x by u v1 minus v1 is 1. This equals to x cos square x. Therefore b dash equals to x cos square x, right? Or we know that cos 2 theta equal to 2 cos square theta minus 1, or we can write it as 2 cos square theta minus 1 equal to cos 2 theta. Now take this minus 1 to RHS, then we'll get 2 cos square theta equal to 1 plus cos 2 theta. Now take this 2 to RHS, then we'll get cos square theta equal to 1 by 2 of 1 plus cos 2 theta, right? Now just replace cos square x with 1 by 2 of 1 plus cos 2x. Then we'll get x times 1 by 2 into 1 plus cos 2x, or we can write it as 1 by 2 of x of 1 plus cos 2x, right? This is equals to 1 by 2 into x plus x cos 2x, which is our b dash otherwise. Okay, we know that b dash is nothing but derivative of b with respect to x, which is equals to 1 by 2 of x plus x cos 2x. Let's now separate the variables by taking the differential dx to RHS. Then we'll get db equal to 1 by 2 of x plus x cos 2x into dx, right? Here the variables are separable, so we can perform integration. This gives us integral db equal to 1 by 2 integral, or 1 by 2 of integral x dx plus integral x cos 2x dx. Here we are having x integral x cos 2x dx. Let's apply integration by parts formula to evaluate integral x cos 2x dx. Okay, we'll find it separately for our convenience in order to avoid mistakes. Integral x cos 2x dx. Here the integrand is of the form product of polynomial and trigonometric function. Consider polynomial function as u and the remaining part as dv, and apply the integration by parts formula. Integral u dv equal to uv minus integral v du. Here u is x and dv is cos 2x dx, right? Differentiate on both sides with respect to x. Then we'll get du by dx equals to derivative of x with respect to x is 1. From this we'll get du equal to dx. And here integrate on both sides to find v. We'll get v equal to, since we know that integral cos a theta d theta equal to 1 by a sine a theta. Then for a equal to 2 and theta equal to x, we'll have 1 by 2 sine 2x. Now apply the formula integral u x into dv cos 2x dx equal to u into v. U into v is 1 by 2 sine 2x minus integral v 1 by 2 sine 2x into du is dx, v du, right, into dx, it's dx. This gives us x by 2 sine 2x minus 1 by 2 integral sine 2x. Since we know that integral sine a theta d theta equals to minus 1 by a cos a theta. Then for a equal to 2 and theta equal to x, we'll have minus 1 by 2 into cos 2x, right? From this we'll get integral x cos 2x dx equal to x by 2 sine 2x minus into minus plus 1 by 2 into 1 by 2 1 by 4 cos 2x. Since integral x cos 2x dx is x by 2 sine 2x plus 1 by 4 cos 2x, this becomes integral dv equal to 1 by 2 of integral x dx is x square by 2 plus integral x cos 2x is x by 2 sine 2x plus 1 by 4 cos 2x plus integral constant say c2. This gives us x square by 4 plus x by 2 2s are 4 sine 2x plus 1 by 2 into 1 by 4 is 1 by 2 4s are 8 cos 2x plus c2. Therefore, b equal to x square by 4 plus x by 4 sine 2x plus 1 by 8 cos 2x plus c2. So we got A and B. Let's now write the general solution using y equal to A cos x plus B sin x. Therefore, the general solution is given by y equal to A cos x plus B sin x. Now substitute A and B here. We have A, x by 4 cos 2x minus 1 by 8 sin 2x plus C1 into cos x plus B, x squared by 4 plus x by 4 sin 2x plus 1 by 8 cos 2x plus C2 into sin x. This gives us x by 4 cos 2x into cos x minus 1 by 8 sin 2x cos x plus C1 cos x plus x squared by 4 sin x plus x by 4 sin 2x sin x plus 1 by 8 cos 2x sin x plus C2 sin x. This gives us, now write the terms involving x by 4 firstly. We'll have x by 4 cos 2x cos x plus x by 4 sin 2x sin x. Now write the terms involving 1 by 8 minus 1 by 8 sin 2x cos x plus 1 by 8 cos 2x sin x. Now write the term involving x squared by 4. We'll get plus x squared by 4 sin x. Now write the terms involving C1 and C2. We'll get C1 cos x plus C2 sin x. Right? Now take x by 4 common from these two terms. We'll get x by 4 of cos 2x cos x plus sin 2x sin x. Now take minus 1 by 8 common from the next two terms. We'll get minus 1 by 8 of sin 2x cos x minus cos 2x sin x plus x squared by 4 sin x plus C1 cos x plus C2 sin x. Since we know that cos A cos B plus sin A sin B equal to cos A minus B and sin A cos B plus cos A sin B equal to sin, okay, minus, right, we have minus here, is A minus B. Now let's apply this formula in the above equation. Cos A cos B plus sin A sin B can be written as cos A minus B minus 1 by 8 of sin A cos B minus cos A sin B is sin A minus B, that is 2x minus x, plus the next three terms remains the same. Okay, this gives us x by 4 cos 2x minus x is x minus 1 by 8 sin of 2x minus x is x plus x squared by 4 sin x plus C1 cos x plus C2 sin x. Okay, if in case you are taking plus 1 by 8 common from the two terms, you'll get plus minus plus, simple. Okay, which is of the form sin x cos 2x plus cos x sin 2x, that is for A equal to x and B equal to 2x, you will get sin x minus 2x here. Okay, that is plus 1 by 8 sine x minus 2x, which gives us plus 1 by 8 sine of minus x. Since we know that sine of minus theta equal to minus sine theta, so you'll get plus 1 by 8 of minus sine x, which is equals to minus 1 by 8 sine x. Again, you'll get the same thing. Okay, if you want, I'll show this for you. Say I'm just taking plus 1 by 8 common from these two terms. Okay, if I take plus 1 by 8 common, I'll get sine x cos 2x minus cos x sine 2x. Right, this is of sine A cos B minus cos A sine B form. Right, now you can write it as sine A minus B. For A equal to x and B equal to 2x, you'll get plus 1 by 8 sine x minus 2x. Since sine x minus 2x is sine of minus x, and you can write sine of minus x equals to minus sine x, since sine of minus theta is minus sine theta. So you'll get minus sine x, right? Or okay, or you can write two more steps. You can write it as sine of minus x. Okay, in the next step you'll get x by 4 cos x plus 1 by 8 of sine of minus theta is minus sine theta plus x square by 4 sine x plus c1 cos x plus c2 sine x. You'll get the same answer. Okay, from this you'll get y equal to x by 4 cos x plus, okay, plus into minus, minus 1 by 8 sine x plus x square by 4 sine x plus c1 cos x plus c2 sine x. Or you can write it as y equal to c1 cos x plus c2 sine x plus x square by 4 sine x plus x by 4 cos x minus 1 by 8 sine x, which is the required solution. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.